In previous programs, we discussed the impact of nozzle types and nozzle sizes on spray droplet size. In this program, we'll discuss how spray droplet size, efficacy, and risk of drift are affected by ground speed and system pressure.
One important thing to keep in mind is what happens as we make pressure changes during our application. I mentioned earlier that as pressure goes up, droplet size gets smaller. As pressure goes down, droplet size gets larger. You might be wondering, well, I've determined the pressure that I need for my application. Why would I change my pressure? And the answer is, if you're changing speed, you're probably going to have to change your pressure. Why does this occur? We mentioned the three things that determine the gallons per acre. If you remember, they were nozzle flow rate, ground speed, and effective sprayed width. Those are the three things that determine your spray application rate. If you're changing the speed during your application, you have to compensate with either nozzle flow rate or effective spray width to make sure that the gallons per acre doesn't change. If you speed up and don't change anything, you actually will be applying at a lower gallons per acre then. In turn, if you slow down but don't change anything, you'll actually be applying at a higher gallons per acre than what you were originally. So as you make speed changes, you've got to compensate with changes in flow rate. An increase in speed requires an increase in flow rate in order to maintain that gallons per acre. A decrease in speed requires a decrease in flow rate in order to maintain the gallons per acre you want to apply at. If you're using an automatic rate control system on your sprayer, it will make those changes in flow rate automatically for you. It does so using pressure. So as you speed up, the system knows it has to increase flow rate. It does so by increasing the pressure. Conversely, if you slow down, the system knows it must reduce the nozzle flow rate in order to maintain that gallons per acre. It will reduce pressure. While this system does a good job of maintaining the right flow rate, we remember that changing that pressure also changes the droplet size. So in essence, what's happening as you increase speed, you're getting a smaller droplet spectra, which is an increased risk of drift. As you slow down, you're getting a larger droplet spectra, which is a potential decrease in efficacy. You're reducing coverage and possibly deposition and retention on the target.